Okay, guys, so we're going to just do a little bit of a warm-up, and then the actual lesson itself will be on the video after this. But for a really good warm-up and for a review, we're going to look at finding the x and y intercept of these two equations. Now, notice that in this case, I'm writing f of x equals x minus 2, and f of x is equal to x squared. If you're not, this is kind of confusing, like I've never seen this before, just remember that f of x you can replace in this, just for our purposes here, we can make that y is equal to x minus 2. We just realize this for f of x, for whatever x is, that's what we're looking for. And that in our case is y. So we're going to change those over to a little bit easier to read if you're not used to that notation yet. Okay, so we need to understand what is the x-intercept and what is the y-intercept. So let's do our x-intercept first. I think that's probably our most challenging one, and y-intercept should be a fairly easy one for you guys to do. So an x-intercept is, so if we draw a little graph right here, we are trying to figure out when does a line intersect our x-axis. So if we logically think about this, that's our x-axis right there. Anywhere on this, when it intersects that, what is x and what is y? Well, we don't know what x is, and that's what we're trying to find out. But if you notice our x-intercept, our y, is always equal to 0. Now, if we were to look at the other way, we'll just go ahead and see this, is that if I had right here, and if I was looking for my y-intercept, again, I don't know what my y is, but I do know that when I have my y-intercept, I know that my x is equal to 0. All right, keeping that in mind, let's go ahead and look for our x-intercept. We just said that when we have our x-intercept, that our y is 0. So let's go and make it 0. And all we do is we solve for our x. Well, in this case, what are we going to do? We're going to add 2 to both sides, and that means our x is equal to 2. Now, that is correct, x is 2, but now make sure that you write it in a coordinate point to where we're going to state it that when x is 2, y is 0. And that's important to know. Okay, let's go over here. So we're looking for 0 is equal to x squared. Now, some students look at this as x squared, and just remember what is the opposite of x squared. It is square root. So we're going to take the square root of both sides. Well, square root of 0, 0 is 0 times 0, so 0 equals x. And so in this case, this means that when y is 0, x is 0. And hopefully you're going to find out that that's an important thing to see. Okay, so I'm going to erase this. So now we're going to look for our y-intercept. Move this up here. So what is our y-intercept? Again, it intersects, we don't know where it intersects on the y, or intercepts on the y, but we do know that x is 0. So we're going to put that y is equal to 0 minus 2. And in this case, we're going to put that y is equal to 0 squared. Just solve for this. Y is equal to negative 2. And again, 0 squared is just 0, so y is equal to 0. So for our answer over here, this is going to state that when x is negative 2, that means y is 0. And over here, when x is 0, y is 0. Well, if you noticed, or hopefully caught on before I said this, if you see that that is 0, 0, that is both the x and y intercept, and that is at our origin point. Now, let's graph these with the information that we have. Now, we don't have a ton of information. We're not going to go into it too much. But if we graph, let's say we graph this one. And, nope, see, You guys see what I did here wrong? That's not negative 2, 0. That is 0, negative 2. Common mistake. We have to make sure we put in when our x is 0, we have negative 2. Super easy mistake to make. A lot of people make that mistake. Okay, so 0, negative 2, which is down here somewhere, and then 2, 0, which is right here. And all we got to do is connect these. And that is generally our graph. Now, if you don't know what this is a parabola. And all we know right now is that it intercepts there. Now, if we've done the section that we just finished, you guys would know that that is an even polynomial, and the end behavior is both up, up. Let's say you didn't know that. Well, what if we were to put 1 in there? Well, what is 1 squared? That is just 1. 2 squared is 4. Right, now let's go the opposite direction. Negative 1 squared is 1, and negative 2 squared is 4. Make sure if you put this in a calculator and you're checking it, you need to put the negatives in parentheses by like so, because this does not equal that. This right here is taking the negative 2 times negative 2. This is actually taking a negative 1 times 2 squared. And that gives you a negative 4, which is not the same as 4. Right, in this case, we draw like so. Bad drawing, but you get the idea. All right, let's do a couple more. And let's see how we do. Oh, I'm just going to make one up randomly. Let's do 3x cubed plus, oops, let's hold off on that one. I think it might be too difficult for us just yet. Let's do this one first. X plus 2, x minus 3 is equal to fx. Now, if we FOILed already, you can FOIL this out, but really this is actually the best way of doing it. So let's go ahead and find our x-intercept. Again, what is our x-intercept? That is when y is equal to 0. Now this is where people are going to get confused. So x plus 2, x minus 3 is equal to 0. And your first thing is might be, well, maybe I need to subtract 2 and add 3 to both sides. You can't do that because they're being multiplied inside those parentheses. But if we were to state, can't we say that if this is 0, no matter what whatever that parentheses is, that's 0, right? Because 0 times a number is always 0. And the same thing here. We pick a random number and we times that by 0, it still equals 0. So we have just talked about if whatever in this side of that parentheses can become 0, we're good. And the same thing right there. So with that being said, what can go into this set of parentheses to make that 0? Well, if you don't see that it's negative 2, the easiest thing to do is go x plus 2 is equal to 0. And in this case, you minus 2 from both sides, and that means x is equal to negative 2. And we'll do the same thing here. X minus 3 equals 0. Add 3 to both sides, and that means x is equal to 3. All right. Now let's just test this out, right? So if negative 2 plus 2 is 0, and negative 2 minus 3 is negative 5. But then we have 0 times the negative 5, which is 0. Let's do 3. 3 plus 2 is 5. And 3 minus 3 is 0. Well, 5 times 0 is still 0. So we're all good on that. So in this case, we have 2 coordinate points. And they would be negative 2, 0, and 3, 0. Alright, let's do our y-intercept. Alright, that's when x is equal to 0. Alright, so now all we're going to do is we're going to plug in 0 to those x's. So 0 plus 2 times 0 minus 3. And what does that equal? Okay, 0 plus 2 is 2. 0 minus 3 is negative 3. And so in this case, that means it's negative 6. So when x is 0, y is negative 6. Okay, now we're just going to roughly sketch this. We don't really know the graph 100% because all we're looking for is x and y intercepts, and that's about it. Hopefully, you guys know in behavior, but beyond that, it's pretty good. All right, plot this out. Okay, so negative 2, 0. So negative 2, 0, 3, 0. And then we're going to go 0 to negative 6, which is somewhere right there. Now, if you've done a couple of these before, you probably know that a parabola, unless there's a shift of some sort, is always going to be symmetrical. So, but if not, that's okay. If all you know is that it goes down here and then it comes back up, that is all I am looking for at this moment. Now, we have done, at least so far, we have done in behavior. And for our in behavior, we need to know if it's, first of all, if it's even or odd. In this case, if we multiply, how many x's do we have? We have 2 x's, so it's even. And also, the coefficient in front of each x. If you notice, there's nothing there right now, but there is supposed to be a 1 if there isn't there. But they're both positive, so that we know that in this case our in behavior is in that direction. Okay. So, let's see if you can do a couple on your own. I'm going to put some problems up here, and then we can pause the video and you see if you got them right. This one might throw you for a doozy because we really haven't talked about it. There's just an X right there. Let's try one more. And then let's see if you can figure out what do we do when I have 3 of these instead of just 1, 2. Okay. You all give that a shot. See how your teacher likes it.